I'm back. I'm just doing this video in 2 parts, okay? Because they take so long to upload. So I'm still doing the math lesson. I'm going to do another example on page 798. All right. So I want you to look at example 2. This is a composite figure. I drew it on the board. It's on the left-hand side of the page. I have it all labeled as they have it in the book. All right. Now, this looks pretty complicated. How do we find the area of an irregular shape that looks like that? Well, it's easy. You're going to have to break it down into separate shapes and add the area of each shape together to get the total for our composite figure. Okay, so our composite figure can be broken up into shapes. This one is going to be broken up into 3 shapes. So I'm going to draw a line, my dotted lines here, and I'm going to make this one long rectangle. So I'm going to have this long rectangle, and I'm going to have my second rectangle here and my third rectangle here. All right. Now, there's a lot of numbers up here. You have to make sure that you have all of your sides labeled correctly. So I'm going to start with this first rectangle on the top. All right, so remember my formula, area equals length times width. All right, I'm going to find length times width for 3 different shapes, add them together. So my first shape, I'm going to redraw this rectangle. It's 12 meters on the top, but now look. It shows me that this line right here is 10 whole meters, all right? But I only need part of this shape here. This side is only part of this length. So how am I, this is the tricky part, how am I going to figure out what the length of this side is? Well, that's easy. If I know that this whole side is a total of 10 meters, and this side is only 8 meters, I'm going to subtract my 2 numbers to figure out what this side is. So I'm going to do 10 minus 8, and it's going to give me 2 meters. So this side is going to be 2 meters, all right? You see how I did this? This total length is 10. But I don't need this whole length. I only need this little piece here. So if I know that from here to this line up here is 8, it's only 8, I can subtract the 2 numbers, 10 minus 8, and that's going to give me the measurement that I need over here. So rectangle number 1, I'm going to do my length times my width, and I know that 12 times 2 is 24. So this is 24 square meters. Oops. Yeah, write it all out. Okay. So now I'm going to erase this so I have a little more room. I need to find the area of this rectangle. So here I have my second rectangle. All right. So I have, now I'm not going to use this number over here because the length of my rectangle only goes up to this line here. So I want to use the 8 and the 3. So 8 times 3 is going to be 24 meters. So it's 24 meters. I have rectangle 1, rectangle 2, and now I am going to do the same thing over here. Again, this is the rectangle that I am finding the area of now. So once again, my rectangle is only going to go up to this line. So I'm going to use 8 times 3 again, and that's going to give me 24 square meters. All right, so I have 3 separate rectangles. I found the area for this one, I found the area for this one, and now I have this one. So what am I going to do? All these answers that I circled, 24 plus 24 plus 24 is going to give me, add up all my numbers here, so I have 2, 4, 6, 7, 72 square meters. It's okay to draw lines and divide up your shape. That's how you're going to have to do it. All right, but hopefully everybody was able to see how I figured out the measurement of this little line here. All right, up to here is 8. From this bottom part to this, where I make my new shape, it's 8. And then this little piece is going to be 2. So if I add 8 plus 2, I get 10. But I'm going to subtract these two numbers to find out, and I'm just checking by adding it back together. All right, so I'm going to pause my video and do another problem. Okay, so now I'm going to move on. I'm going to do the problem on the bottom of page 798, the guided practice. Okay, so here's another composite figure, and this one only has 2 shapes, unlike the last one. So what am I going to do? I need to find the area, but I need to show that I have a measurement for each side. All right, so on your paper, you would just take your pencil and divide it into 2 separate shapes. All right, this is going to be rectangle 1. This is going to be rectangle 2. All right, so what I want to show you, this is the tricky part again. I'm going to erase this number right now so it doesn't confuse anybody. So I have 7 centimeters across the top, and I need to find the length of this side on the bottom here. It does not have a measurement, okay? So how do I do that? Well, I look at the top, because we know that when we are looking at a rectangle, it has to have even sides, all right? So even though this is an irregular shape, this length is still going to be equal to what's on top. Except it's just broken up into 2 separate measurements. So this line up here totals 7. From this line here on the bottom is 4 centimeters. So I have to, in order to find out the length of the side here, I have to look at my top line, think about the total that I have in centimeters, and do a math problem. Do a little simple addition to figure out what this side is going to come out to be as far as the measurement goes. All right, so if from here to here is 4 centimeters, what do you think this is going to be, this side from here to here? If I were to draw this straight line, it's going to have to equal 7. So I have to say to myself, what plus 4 is going to give me 7? All right, because from here to here, this is 4 centimeters. So what is this line going to be? If you find out what this line is going to be, it's got to be the same as this one here on the bottom of the rectangle. So what plus 4 is going to give me 7? Well, that's easy. We know that 4 plus 3 equals 7. So if from here to here, this is the 4, from here to here, this has to be 3 centimeters. So if this line right here is 3 centimeters, then we have found the measurement to what we need on the bottom. Okay? Go back and rewatch that one if you need a little extra help, if you need to see it again. All right, so rectangle 1. I'm going to circle my rectangle here. I know that I'm going to use my formula. I'm going to plug in my numbers. 5 times 4 equals 20 square centimeters. Remember, we're doing area, so we have to put it in square meters, okay? I just simply found the area of my first rectangle. Now, I know that all three of these sides are 3. This right side is 3, the bottom is 3, the top is 3. That means this side has to be 3. So I have a perfect square. All right, so what is the area? Area equals length times width, and I'm going to put 3 times 3, and I'm going to get 9 square centimeters. Okay? Now, this is the area of my first rectangle. This is the area of my second rectangle. I can't leave it like that. I have to add both of them together. So 20 plus 9 is going to give me 29 square centimeters. All right? So you have to think, you have to make sure that all of the sides have a measurement. And you might have to use, because here again, this line is equal to this line even though it's broken up. So this is my 4, and I know I have my missing number here. This other line has to be 3. All right? So I'm going to pause my video and I'm going to show you another problem. Okay, so here's another problem on composite figures. All right, I've been doing this too long today already. So another shape, we have most of the sides labeled in meters. How are we going to find the total area? Well, we're going to break it up into 2 separate shapes, find the area of each shape, add them together to get the total area of this irregular figure, okay? But before I do that, I want you to look at this line right here. Once again, does not have a measurement. We have to find out what that measurement is. And in order to do that, we're going to have, this is going to help us. This number on the bottom is 11. It's the length of this total line for both shapes. Now, this measurement, this line, has to equal what you see up here. Well, I've got a little piece of this line right here that equals 4 meters. Okay? This is 4 out of the 11. So I have to think of my addition again. If I know that this whole shape, even though it's broken up, if I know that this whole shape is 11, it has to equal this, and I have 4, what is this going to be? Think of an addition problem. 4 plus what number is going to give us 11? All right? Well, that's easy. What is 4 plus 7? 4 plus 7 is 11, right? All right, so this number has to be 7 meters. Now I'm all set. Now I can go ahead and find out the area of my composite figure. All right, 1 rectangle at a time. So I'm going to break it up. This is going to be rectangle 1. This is going to be rectangle 2. So what are my measurements over here? I'm going to use my formula. 6 times 4 equals 24 square meters. Okay? Boom, done. Now I have to figure out the area of this shape. I'm going to use these 2 numbers. This is rectangle number 2, all right? 7 and 4. I'm going to use my formula. Area equals length times width. I'm going to plug in my numbers. Length is 7, width is 4. and I'm going to find out that this is 28 square meters. So I'm going to quickly add my two numbers together. All right, these are my area. This is my area. I'm just going to add them. What do I do with my eraser? Add my two areas together. This is going to give me 52 square meters. All right, pretty simple. Just make sure that the two lines add up and are equal to the larger one on the bottom or the side or whatever it is. You can definitely use the distributive property. You can use repeated addition. If you know how to do that 4th grade math that I taught you, you can use that to find out how to, or when you have to do a larger multiplication problem. All right, but it's pretty simple. So this is pretty much it with composite figures. Break it down into two separate shapes. Make sure you have all of the sides accounted for. They all have to have a label, and then once you find the area for each one, add them together. All right, I'm actually going to ask you to do the homework page for this lesson, and it was 797. I just want you to do the homework page. Let me see what page that is. Sorry, it's going to be 801, 802. If you would like to practice any of the problems in the lesson on page 799, you're more than welcome to do that. This is one where we probably need a lot more practice, but it's actually just going to be the homework page of 801, 802 for now. Now, I want you to give it a try. Do the best that you can. Email me if you need some help. Rewatch the video a couple of times to make sure you understand it, and that's pretty much it. The rest of the chapter, I don't even think I'm going to have to really teach. The next lesson that you're going to be doing are word problems, where you're just drawing a diagram, drawing a picture, and you guys know how to do that already. And then we have a check my progress, we have a chapter review, and that's it. It's done. We've done everything there is in this chapter, and then we're going to move on. So I don't know if you'll see me in another math video this week, but I will be checking in with you and probably giving you some more information. All right? So I will see you next time, guys. Do a good job doing your work. All right. Bye-bye.